Hey everybody. Okay, now that we really understand how to work a square root and a cube root, our job today is to work any size root. So a root can have any size index because remember, a root is undoing an exponent. And if an exponent can be any size, therefore a root can be any size. So if we look at our PowerPoint, the first root I want to evaluate today is the fourth root of 16. So our index is a 4. And what that means is that we're trying to think of a number, if we multiply it 4 times to itself, would give us 16. Now, unlike when we did square roots and cube roots and I made you memorize a list of numbers, we're not going to memorize a list of numbers for every single root. Okay, square roots and cube roots do come up the most in algebra, so therefore we should know those perfect square and perfect cube numbers. But I'm not going to make you memorize a list for the fourth roots. So what we're going to do here is trial and error. We want to think of a number that if we multiply it 4 times to itself would give us 16. So if we start out with our first whole number 1, 1 times 1 times 1 times 1 would still be 1. So that's not the fourth root of 16. Let's try 2. 2 times 2 is 4. 4 times another 2 is 8. 8 times another 2 is 16. So that works. If we take the number 2 and we multiply it 4 times, we would get 16. Therefore, the fourth root of 16 is 2. See how simple that was? All right, let's try a root that's like the fifth root. So in my next expression, I have the fifth root of -1. So my index is now a 5, and that's telling us we're trying to think of a number that if we multiply it 5 times to itself would give us our radicand -1. So again, if we start with a basic, let's start with our first whole number 1. What's 1 times 1 times 1 times 1 times 1? Well, if we multiply 1 5 times, we would still get +1. That's close, but that's not what we want. We want it to come out to be a product of -1. So what happens if we multiply -1 5 times? So let's try that. -1 times -1 would be a +1. Then we multiply that by a -1 and we get a -1. Then we multiply that again by a -1, so a negative times a negative is a positive. And then we multiply that again by a -1, and a positive times a negative is a negative. So yes, indeed, if you multiply -1 5 times, you would end up with -1. Therefore, the fifth root of -1 is -1. Now, what I want you to do is see a connection. The fourth root was an even index. The fifth root was an odd index. You could directly relate that to square roots and cube roots. Okay? A square root is an even index of 2. So fourth roots are like square roots because they're even index. The fifth root is like a cube root because cube root is an index of 3. So a 5 and a 3 are both odd index. And we learned you can do a cube root of a negative number. Therefore, you can do a fifth root of a negative number. So those rules still apply. All right, let's look at one more expression in our PowerPoint. We have the sixth root of -64. So again, what's our index? It's a 6. So I want to multiply a number to itself 6 times. That would give me -64. So again, if I start out with 1, 1 times 1 times 1 times 1 times 1 times 1 would just give us 1. That doesn't work. So let's try 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. So if I take the number 2 and multiply it 6 times to itself, I would get out 64, a +64. So I want a radicand that's a -64. So what happens if I multiply -2 6 times? Well, you know your rules. A negative times a negative makes a positive. So if we did -2 times -2, that'd make a positive. Then we multiply that to -2, that'd make a negative. Then we multiply that to negative 2, it would be back to a positive. Then we multiply that to a negative 2, that's back to a negative. And lastly, by another negative 2, we're back to a positive. So we should all realize you cannot take a negative symbol and multiply it 6 times to make a negative. Therefore, we cannot do the 6th root of negative 64. And we've already discussed this. If you cannot do the root, you say the answer is no real root. Now, this should make sense. If you recall, the 6th root is an even index, just like the square root is an even index. And we learned you cannot do a square root of a negative number. It will never have an answer. Therefore, any even index, you cannot do a negative radicand and get a value. All right, let's try some more examples. Let's go to the whiteboard.